This is Phil Coatman, and I'll be talking about automated vehicle state policy issues. A quick overview of this talk is that I'll first talk about getting past automated vehicle safety rhetoric and a quick view of the different aspects of autonomous vehicle safety that are often not talked about. And then I'll cover a number of policy points from the point of view of state regulators and state legislators who need to grapple with this technology and figure out what the rules should be for testing and deploying the technology in their states. And I'll end up by revisiting some common myths to make sure everyone understands what the technology can and can't do. The first thing is we always hear robotaxis are not prone to human error, therefore presumably they'll be safer. That's a big myth. It is true that they don't make human error mistakes, but they make robot error mistakes instead. And so the question in the end is whether the robot errors are worse or better than comparable human driver errors, and we still don't know yet. Some of the robot errors that get made are things that it's hard to imagine a normal, competent, unimpaired human driver making some of these mistakes or making them to such a degree. One incident involved not one but two robotaxis driving down a road. There were some down power lines, and they dragged the down power lines down the road, including some emergency tape down the road hooked onto their sensors on top. And you would hope that a human driver would figure out pretty quickly that driving through emergency scene tape and dragging power lines hooked to your vehicle down the road is probably not a good idea. And so this is kind of a robot-style error. But another issue that comes as somewhat of a surprise is they also make mistakes that look just like human errors. For example, there's a robotaxi that drove into wet concrete in what was said to be a reasonably well-marked construction area. Now, yes, human drivers make this mistake on occasion. I get that. But the promise was that these robotaxis would not make stupid human mistakes. And here's a robotaxi making something that looks pretty much like a human stupid mistake. Another one is driving into construction areas. Now, this one, it's possibly involved with a remote operator, but if you're deploying a robotaxi, the remote operator is part of the system, and what matters is not which human you find to blame it on. What matters is the net safety and whether these things out on the roads are obeying traffic rules and driving into a well-marked construction area where the whole road is closed off, there's a flagman and all this stuff. That's not okay. That's not something you should do. And again, yes, human drivers do that on occasion too, but we were promised robotaxis that don't make stupid human mistakes. And we have a bunch of incidents to show that's not how it's turning out on public roads. We now know that the safety rhetoric of these things are here to save us, they're going to be perfect. Not that every company said that, but some of the companies certainly wanted to imply that. We now have some evidence that that's really not how this works. So the question is, well, what's really going on here, and how safe will they be, and where does the bar get set? So let's start with getting past some of the rhetoric. I'll start here, and then we'll revisit this at the end. The reality is nobody knows when or even if, but mostly when, autonomous vehicles will be safer than human drivers. When there are claims of reduced fatality rates, those are purely aspirational. There are companies who have a reasonable basis for a prediction, a model saying, yeah, we're on track to be at least as safe as a human driver with regard to fatalities. But no one has the data to get there, and I'll revisit that again later. Some human drivers drive drunk. That's right. But on average, human drivers are still pretty good and adaptable, and I'll be showing some numbers later. And so it's really actually quite difficult to beat a human driver for safety, especially if you take the drunk and impaired ones out of the pool. Human drivers, while imperfect, are remarkably good at dealing with what the heck is that and weird, odd situations that they've never been trained on, but they muddle through. They find a way. Computers are terrible at that. Machine learning can fail in novel situations. The idea for machine learning is you train the computer with a bunch of examples, and what it sees in the real world, it says, okay, that's close to this set of examples, now I know what to do. So when it encounters something it's never been trained on, it's kind of at a loss, and it doesn't have common sense, so it often does something just completely inappropriate that a human driver would never think to do. And we saw a couple pictures of things that are, some human drivers make those mistakes, but some things a human driver probably wouldn't unless they're impaired or otherwise a bad driver, but the point was these robotaxis won't be like that. Computer drivers in particular can be imperfect. For many years, what the robotaxi industry would say was, well, we'll never hit something like a bus because our LiDAR will see it, and because the LiDAR sees it, we won't hit it. And that was graphically illustrated to be a false statement when a robotaxi actually hit a bus in San Francisco. Now, in this case, there was a logic error, and the short version is it was following the front half of an articulated bus, and it decided to ignore the back half of the bus, and so it hit it. That kind of logic is not something you would expect of a human, but that's exactly what you might think of a computer failure, and sure enough, it happened. So we can't say that just because they have good sensors, they will never make a mistake. We can't say just because it has a whole bunch of cameras and LiDARs and radars and sensors that it won't miss a bus right in front of it, because we just saw it happen. The reality is you cannot assume these vehicles will be safe. They have to be engineered to be safe, and that engineering is a lot of work, a lot of time. We hope the industry gets it right, but you can't simply say, well, computers don't make mistakes, therefore they'll be safe. We're seeing that play out on public streets. It's simply not true. You have to also have the engineering to go with it. Now, what does it mean by safe? Well, the big narrative that the companies are pressing, and it's a reasonable narrative at a first step, is to talk about reducing fatality rates. And so the industry will say, well, we need to be at least as safe as a human driver on average. Now, that should mean injuries as well as fatalities and potentially property damage as well. But the narrative always comes down to fatalities. We're here to save lives. Okay, that's a great motive. What does that mean? Well, in San Francisco, depending which of the recent years you look at, there's about 75 million to 125 million miles between fatalities in San Francisco. Let's round it off to an even 100 million for discussion, which is in the ballpark of the national average, which also fluctuates up and down. That includes the impaired drivers. So where's the bar set for as safe as a human on average? It's 100 million miles between fatalities, including all the drunk human drivers. If you take out the drunks, it's going to be a lot higher. But that's not all. There are other things that you have to consider. If you had 100 million miles between fatalities, but all those fatalities were pedestrians and not a single was a passenger. Now, I'm not saying we're going to get this outcome, but I'm just illustrating. If all the risk shifts on pedestrians and none are for occupants, that's going to be a problem, especially for pedestrians. And so you can't get a good average, but at the same time impose risk disproportionately on some segments of the population. That's not okay. So safety is not only improving or at least meeting the average, it also is avoiding disproportionate risk on identifiable segments of the population. And there's another thing. It's not okay to run through red lights because, well, my car thinks it's probably fine. I'm going to run through red lights and I reduce the fatality rate. So why are you giving us a hard time about running through red lights? That's not okay. The cars are supposed to obey the traffic laws like everyone else. So running red lights, stop signs, other violations of road rules that are not driven by exigent circumstances are not okay. They have to follow the rules. And if they don't like the rules, well, that's a great discussion about having the rules changed. But the companies can't simply decide not to follow the rules. They should also conform to industry safety standards because we won't know how the fatalities turn out for a long time. And conforming to safety standards is how every industry other than this one achieves safety. The industry has written its very own engineering safety standards, consensus from industry representatives and others, and they should be following them. In particular, at the state level, you should consider SAE J3018. This is not how you build the robotaxi. This is about how to ensure that testing is performed safely and is clearly a state kind of regulation that has nothing to do with the equipment safety that the federal government worries about. And finally, you need to address other ethical and equity concerns, such as local preemption and manufacturer accountability for harm that I'll go into in this talk. So when you say safe doesn't just mean lower fatality rate. It means you have to address all 5 of these concerns, or at least some stakeholders can reasonably say, now, I'm sorry, you may have a nice number, but that's not safe enough for our needs and for our legitimate interests. Now I'll go through several policy points. The first policy point is social benefit. One of the things that the companies promise is we're going to have all these great societal benefits. We're going to help the disabled. We're going to make sure that food deserts get service, and we're going to have equitable transportation and all these things. And if those come to pass, those are great. But right now, we're not there yet. The benefits only accrue after the AVs are both safe and reliable. And we're going to need more than 100 million miles to confirm reduced fatalities. So the question is not a billion miles from now, how will things look? That's the great far future. It's going to be years before we get there. The question right now is, what's the societal benefit look like while we're trying to get there? And in particular, in the near term, safe might mean lower reliability. We're seeing many, many incidents of robotaxis stalling and clogging up streets and even impeding emergency responders. And the reason given is, well, it was not safe to proceed, so we shut down in the name of safety. Well, that's well and good as far as it goes. But there are consequences for shutting down the road, especially if it's for 5, 10, 15, 30 minutes rather than 30 seconds. And so those kind of consequences, those negative externalities, have to be taken into account when you look at near-term societal benefit. So if you're going to give permission for these things to run, ask the hard questions. What will the benefits be right now? You can be promised benefits disabled, but what if they deploy with no wheelchair access? They can promise they're already saving lives, but there's no data to actually support that. That is their best estimate or their best guess, but when you have 1 million miles and the fatality rates are more than 100 million miles, you don't actually know how it's going to turn out. And they often promise unprofitable thing without a regulation. So, for example, we're going to make sure we have wheelchair access, but we don't have it now. Trust us, it will come later. Well, unless there's a regulation requiring them to provide that, how do you know it's actually going to happen? So there are a lot of promises up front, but without a commitment to make them happen long term, we don't know how that will turn out. Moreover, the companies are asking us to put up with a lot of negative consequences for benefits that are out in the future. What about the benefits now? Those aren't as substantial. The other thing to ask is, what are the public costs and where they're going to be right now? You may have congestion, you may have blocked emergency responders, you may have potential harm from still underdeveloped software operating on public roads. There are going to be some costs, but you cannot simply assume the benefits will automatically accrue, and you cannot simply assume that everything will be perfectly safe because we're seeing otherwise play out on public roads. The next policy point is public road testing safety. There is no such thing as driverless testing. When you take the safety driver out of a robotaxi or a robotic truck or any other automated vehicle, when you take the safety driver out, you are done with safety relevant testing because you're not testing with a test driver to intervene if something goes wrong. You're just deploying to see how it turns out. And if you don't know that it's acceptably safe before you pull the driver out, what you're doing is, well, you're crossing your fingers and you're hoping it comes out okay. The safety driver should stay in until safety is proven. And the safety driver should follow the SAE 3018 testing safety standard, which talks about how to train and qualify drivers, how to run test plans. It has nothing to do with the equipment. It's how to make sure you're safe during testing. By the way, any car company that says their software is beta is conducting road testing, which should only be done with a qualified engineering driver, not with a general public, not with a retail customer, and that includes SAE Level 2 autopilot style systems. If it's testing, you don't know if it's safe by definition, because if you knew it's safe, it wouldn't be testing anymore. So testing potentially unsafe software that is likely to have bugs in it should not be done by retail customers and certainly should not be done without any human driver at all. This was brought to light in 2018 with a tragic fatality that Uber ATG had a test driver, but they had a poor safety culture. They weren't testing as carefully as they should have. They had a fatality. And the SAE 3018 standard I mentioned was updated directly in response to the lessons learned. The industry should follow the lessons learned from that fatality so they don't have to repeat that outcome. But right now, there's no company I'm aware of that will publicly say they actually follow that industry testing safety standard. That should change. Driver out testing is reasonable to test a business model. Once you know your vehicle is safe, it's fine to do some testing of how much will people pay and what routes are profitable and what's our transit time, all that kind of stuff. That's great. But safety needs to be a given before you take out the safety driver. Otherwise, you're just rolling the dice to see whether it's safe or not. And the way you're going to find out it's not safe is you're going to have a crash with an injury, or we hope not, but maybe a fatality. Another policy point. Municipal preemption. Many states in the U.S. right now have a municipal preemption clause in a state statute. And the idea is that companies have been pushing for this very hard, state by state across the U.S., saying, well, if you allow cities to not allow testing, they're going to forbid testing. The reality is that right now, cities have no defense against companies coming in and testing if the state decides it's okay. And how's that working out for San Francisco, where we're seeing a ton of disruption of both traffic and emergency responders? That's a problem, and San Francisco can't do anything about it because they have a state-level municipal preemption clause. Those clauses take away localities' ability to regulate their own streets, to regulate the unique and special circumstances that they have in their locality, and that's turning out to be a real problem. Now, this is not an all-or-nothing thing. The discussion is always, well, if we give them one bit of control, they're just going to ban us. Well, you don't have to do that. There's a middle ground here. You could say that cities and municipalities can regulate or restrict operations responsive to specific local conditions. For example, municipalities could forbid testing with the driver in, because driver out testing isn't testing, it's just deployment. They could forbid testing with a driver in school zones during student transit times, near parades, near fires, near First Amendment events, near construction, and maybe forbid deployment in early cases during those, because those are pretty chaotic. And it's not necessarily the case that the city is able to provide real-time data about where a free-flowing First Amendment protest that won't even tell the police where it's going to be next. How do you predict that? How do you put that out? Well, you can't. So the best thing may be to put a keep-out zone around those. But this does not mean that the state has to require that. It means that the municipality should be given the flexibility to impose specific requirements in response to specific risks and hazards as needed to make sure things stay under control. They should also be able to selectively suspend service. If a robotaxi runs over a fire hose or interferes with a firefighting scene, gets between firefighters and a burning car, for example, the firefighters should be able to ask the city to ban robotaxi operations anywhere near within a couple blocks, say, of a fire response scene until that gets sorted out, and then roll it back. They should not be at the mercy of the state to make those decisions. It takes too long, and the states don't have the necessary local knowledge to be nimble and flexible and respond. The municipalities also need to be able to enforce their own traffic laws. There needs to be a way for the state to provide that a police officer can give a robotaxi a ticket for running a red light. In some states, that's not actually possible because the ticket is associated with a human driver. And if there's no human driver, there's no one to give a ticket to. And so those kind of things need to be cleaned up. The next policy point is that SAE Level 2, 2+3 vehicles are actually a huge issue. They're not being sufficiently addressed by legislatures either at the state or the federal level. These vehicles are already deployed on roads in large quantities, and we're seeing fatalities and injuries due to driver complacency. The idea is when you turn on automated steering, the human driver has trouble paying attention. We've known this kind of thing is a problem for cars since the 90s. We've known that people are bad at paying attention to boring situations since the 1940s. This is not something that's fixed by telling the driver to pay attention. This is fundamental to human nature. People are really bad at monitoring boring things, and that's not going to change. People aren't going to change. Now, there's technology such as driver monitoring that may help with that, but simply telling drivers to get better and blaming drivers for crashes will not stop the crashes from happening. And what do we do in regulation? Well, basically nothing. Every once in a while, there's a recall for something that's really egregious, but there's no regulations requiring these systems to be things that can be supervised by an ordinary human driver with good outcomes. And we're seeing the consequences. In 2023, the stakes are being increased with the advent of so-called Level 3 vehicles. These are ones where the driver is told by the manufacturer, you know what, it's okay to look away from the road once you've pressed the on button and the system is engaged. So this is, in this case, it's a low-speed traffic jam pilot, but Level 3 in general is the driver does not have to pay attention at all while the feature is activated, but they have to be there to take over if the feature says, hey, I need you to take over now. And what can the driver be doing? Well, here's a picture. This is a real thing that Mercedes-Benz is selling the game of Tetris to play on the dashboard, so you can actually play Tetris on the dashboard, and this is their marketing video of someone playing Tetris on the dashboard while the car is driving itself. Well, if that works and it's safe, that's really cool. It's really great. But the question is, what's the criminal liability? If this vehicle, that driver playing a game on the dashboard, hits and kills someone, now it's a highway, they're not supposed to be people, but people show up on highways. There's a crash scene. There's all sorts of things that happen. What if this vehicle hits an emergency responder or a pedestrian and kills them? Who goes to jail? Who's liable? Well, that's an interesting question. And it's not resolved. Now, Mercedes-Benz says, oh, we take responsibility for the correct performance of our system. But when push comes to shove and the reporters ask them for a written statement on that, what you get back is they're talking about product liability. Oh, we'll stand behind our product liability, but their statements don't touch on criminal liability or even tort law, what happens in the wrongful death lawsuit. And so, at least in some states, the vehicle operator or the vehicle owner can be on the hook for these potentially very serious issues, and it's a very unclear area of law right now. That should be fixed before this technology deploys, because who wants to be the driver who serves as the poster child for that kind of, I don't know what's going to happen, let's find out. There needs to be a clear duty of responsibility for the computer driver. There needs to be a concept of a computer driver that's in charge of the car when the human's been told it's okay not to look at the road. And when the computer's driving, the manufacturer should be responsible for tort law and for criminal law beyond product liability. There needs to be a defined non-zero safe harbor transition time. So if the computer says, hey, you got the ball now, and the driver looks up and they're about to hit someone, that's not automatically the driver's fault. So there needs to be several second period, perhaps 10 seconds, where the driver is not at fault if they're trying to get back into control of the vehicle because the vehicle told them to do so. And it should be also the case that liability attaches to the manufacturer if there's an inadequate driver monitor. People have trouble paying attention. The driver monitor should enforce the required level of attention. If you have driver monitoring theater or an inadequate driver monitor and the person's not paying attention, the manufacturer needs to have some role in that. You can't just blame the person, because blaming the person won't stop the next crash. I have a detailed proposal for state regulation on this, co-authored with Professor Wyden from University of Miami School of Law, and those details are pointed to on a slide at the end of this presentation. The next policy point, federal versus state regulation. Now, this is why it gets tricky. The feds regulate equipment, the states regulate drivers, but what if that computer driver, that's a piece of equipment, how does that sort out? And this can get tangled. But there's a proposal that's fairly straightforward that sort of untangles this in a way that I think will not break things, but is still useful and still result in safety. The first is NHTSA should still control equipment as they do now, and the ability of the computer driver to adhere to state laws. So there's an ANPRM, Advanced Notice of Proposed Rulemaking, for an automated vehicle framework. And what it says is the company should follow their own industry consensus safety standards to ensure safety. That's been out for years. There are comments, and the comments have not been responded to yet. That needs to move forward, and that will go a long way to fixing the federal half. But that's about the equipment. The federal law should not say what the behavior needs to be. The feds shouldn't be telling whether right turn on red happens all the time or none of the time. That should still be a state thing. So they should control whether the computer driver can execute the applicable state laws, whatever those might be. The states should control the computer driver behavior. So they should not be saying whether you need 2 computers or 3 computers in case one fails. That's a NHTSA problem. But the state should be able to say that the computer driver has to be held to the same duty of care as a human driver, and that includes not breaking traffic laws. That includes not displaying reckless driving, and so on. So the states can go after the behavioral aspects of what happens when this thing operates on the road. They can give traffic tickets. They need the ability to revoke driver's licenses if one of this thing keeps breaking the law. You should hold them to the same standard as human drivers. If a human driver breaks the law consistently, probably yank his license. The same should happen to computers. It should not be the case that computer drivers get an automatic license with no ability to even know that they drive well, and much less no possibility to revoke the license. The municipalities also need the ability to enforce and report negligence to the state DMV. So if the computer driver behaves in a reckless way on local roads, the local police should be able to ticket it just as they would a human driver, and they should be able to report the behavior to the state DMV for the state DMV to consider revoking the license, assuming that that's an appropriate response. A few other policy points wrapping up here. One is economic impact. The saturation of fully automated vehicles is decades away. It's been decades in the making. It's not going to be the case that next year, all of a sudden, every car on the road is fully autonomous. That's not going to happen. The average U.S. car is more than 12 years old at this point. So we're looking at 10 years before you have a significant fraction, and 20 or 30 before you get most of the cars switched over to autonomous. This is a multi-decade kind of progress. And that assumed they're ready, which they're not ready. It may take another 10 before they're even ready for that process to really start. For the foreseeable future, this is going to be a city-by-city, route-by-route kind of expansion of this technology, and it will be coexisting with human drivers for decades. Now, even when we get to the point that there are a whole bunch of self-driving trucks, for example, or self-driving robotaxis, there'll still be humans needed for remote support, maintenance, and testing. Testing is never going to stop. Every new software update needs safe testing. Every change in the environment needs testing. So there will always be humans required, but they'll be in different roles. And we'll still need people for the last few feet of delivery, or maintaining cargo security, etc. So things will change. Technology always changes jobs, but they won't change to the point that humans are simply no longer required. That is a long, 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 long way off, too far away to plan for at this point. The next thing is required arbitration is an issue. Arbitration impairs transparency and therefore safety, because if there's a secret outcome to an arbitration proceeding, whatever safety lessons might have been learned are not made public, and there's no pressure on the industry to change or to learn the lessons. And it also degrades the balance of power if mandatory. To be clear, if both parties genuinely want arbitration, that's fine. But the issue is required arbitration where someone who may have been harmed by an automated vehicle needs to go through arbitration and has no choice in the matter. That in the long term is going to impair safety. Finally, there are a number of equity issues that need to be addressed. For example, will underserved populations benefit without regulatory mandate? There may be a claim that, well, autonomous vehicles will provide transportation equity to several different stakeholders, but if the regulators don't require that and the companies find it unprofitable to do that, you may not get that outcome even though it was promised. The next one is that will road testing impose risk on the vulnerable? There are reasons why one might test robotaxis in low-income areas. For example, the expected cost of doing harm to a resident may be lower. Now, while we don't know if any companies are behaving that way, that's a possibility that should be kept an eye on, and the municipalities should have the ability to, for example, review testing plans to make sure they're not exposing vulnerable populations to elevated risk compared to other populations within their city. Getting to the end, let's do a quick list of myths. These are things that we hear the robotaxi companies and the autonomous vehicle trucking companies and other autonomous vehicle companies talk about, and they just aren't true. So let's just dive in here. First, humans are terrible drivers, and 94% of fatalities or 94% of something are due primarily to human error. Both of those statements really aren't true. Human drivers are actually pretty good, especially if you take out the drunks. And the 94% human error is just a misattribution. If you look at the source of that quote, one sentence says 94% of some aspect of the crash had a human participation, but in the very next sentence it says that does not mean we're blaming the drivers. It's just wrong. There's no basis for saying that. Computers lack common sense. They're going to make mistakes too, and nobody knows how this is going to turn out. So it's not true that computers are automatically better than people. Both of them make mistakes. The next one is we have 1 or 2 or 3 or 5 million miles of testing. Look at us, we have 5 million miles of testing. Well, if you've gone 5 million miles without an injury, that's pretty good, but the companies haven't managed that. If you've gone 5 million miles without a fatality, that's good, but it's only a start. And now to be clear, some companies may say we had an injury or fatality and it wasn't our fault. But the number you're comparing against is not at fault. If it's 100 million miles between fatalities for the US or for a city, it's not 100 million miles between at-fault fatalities, it's 100 million miles between all fatalities. And it doesn't matter whose fault it is. If you have a higher fatality rate, that's bad regardless of fault, and if it's lower, that's good regardless of fault. All that having been said, we've got 5 million miles of testing. Well, okay, 95 or more million miles to go before we know how it turns out. I understand some companies have very sophisticated predictions that they're on track to winning that race to reduce human fatalities, and that's great. But we don't know how the race is going to turn out until we see, and we're a long way from that. So it's okay to say we have 5 million miles of testing, but that doesn't actually prove you're safer than a human driver. The numbers are a lot bigger to actually get the kind of evidence needed to prove that. The next one is level 2 or level 2 plus autopilot type systems make cars safer. There have been tons of claims about this. I've never seen any data that supports that. Now, the tricky bit is companies will say ADAS makes cars safer, therefore level 2 is safer. Well, you have to unpack that. Advanced driver assistance systems, ADAS, are things like automatic emergency braking. Automated steering is not an ADAS feature in those studies. So yes, automatic emergency braking absolutely helps, but sustained steering is not in those studies. There is no data I've seen that says sustained steering improves safety, saves lives. And there is a pretty good study that shows that it actually slightly decreases safety. And that was a comparison of the feature turned on versus the feature turned off in the same car. And it turns out it crashed a little bit more with autopilot turned on than off. So you can't believe this technology will automatically save lives. The next myth is we, the manufacturer, take responsibility, followed by whisper, for product liability. Well, product liability, of course they have to take responsibility. That's kind of the law. But the more urgent issue is not product liability, it's tort and criminal liability. If there's a crash and the car is driving, does the driver go to jail? Does the driver have to hire a lawyer because it's unclear whether it's the driver's fault, even though they were told by the manufacturer it's okay not to watch the road? That's what's on fire there. And we need to clean up that system to make sure everyone understands what the rules of engagement are there. Because right now, it's kind of a mess. And the last myth is that current laws and regulations are enough. Well, I just said liability is a mess. It turns out there are a bunch of places in the current laws and regulations where we don't know how it's going to turn out. Not knowing how it's going to turn out favors the companies because that allows them to buy time, and they're the ones with the big teams of lawyers. So it needs to be a level playing field for everyone else that isn't the self-driving car companies to have clear rules so we know how things are going to turn out. Some of the issues are liability issues, software safety regulation, for example, the companies following their own industry safety standards, and closing the level 2 plus loophole, which is where we have a car that pretty much drives itself almost all the time, but not quite. But the fine print says, but it's the driver's fault if it crashes. That needs to get addressed. Also, there's very little regulatory pressure to make sure the promised benefits happen. There's lots of promises. Some of those may come to true, but some of them may not come to pass even if the technology can do it just because the business model doesn't support it. And so if you want to have the outcomes, you need to have regulations to ensure the outcomes actually happen. Finally, there's a slide here with some resources, and I will just leave this up for a second, but the printed copy of this, the Acrobat copy of this, will have clickable links so folks can follow up.